Welcome to video 14, inventory management. We'll do the economic order quantity model, EOQ model, and the price break model, right? Suppose that you are the new operations manager of the company Crocodile. Okay, this is the company where you work as an operations manager, and you know that this company is releasing an order for a specific component of 450 units per order, and is releasing this order once every 25 days. Units order, an order every 25 days. Probably you remember this statement for another exercise, but this is different. Okay, this data is the same, but some other things are different. This will help you to work out with a year of 365 days the annual demand. Okay, the annual demand that this company makes on this component, right? So if we check that 375 days in a year, and we know that we have one order every 25 days, and we know that one order every 25 days, and it's 450 units per order. What you get is that the annual demand is 6,570 units. Okay, this is equal to another statement that you saw. By the way, you have this Excel, all right, but this Excel is not totally automated. So, especially in the moment of choosing the right potential optimal, when you change data, it doesn't work because it's not automatic. Okay. All right. So, by now we know demand. This is demand. Okay. Demand. Okay. The cost of order, every time that we release an order, we will incur a cost of 500 euros. Euros order. Okay. And the inventory holding cost is 10% of the acquisition cost. So 010C. 010C. And the cost is 1,500 euros per unit. All right? So now we have all the variables that we need to determine the optimal order size. This is what we want to do. The company is using this order size of 450, and we suspect that possibly is not the optimal order size, and we want to know which is the optimal order size. So what we'll do is to use this equation. Okay, Q, this means that this is an optimal, 2 multiplied by the demand, 6,570 multiplied by S, 500, divided by H. And H is the 10% of the acquisition cost. This is the acquisition cost, so H is 150. All right? And this will give us a result of 209.28 units per order. Okay? This is the optimal order size according to the EOQ model. All right? You try to convince your boss that this is the optimal order size, and the boss tells you, "You're the new one in here. Are you sure? Can you prove that this is so?" Yes, of course, I will prove it. We'll take the equation of the total cost. This is quite a long equation, and if you try to learn it by heart the way it is, it won't be very easy, no? This is more focused. Yeah, okay, this equation. But you must know what is the meaning of this equation, okay? D multiplied by C, so the demand multiplied by the acquisition cost is the total cost, the total acquisition cost, let us say, okay? This is total acquisition cost. What is this? This is the total ordering cost. If we forget for a moment about S, D divided by Q is the number of orders that we will release in a year, okay? If we divide the demand by the size of each one of the orders, we get the number of orders, right? And then we multiply this number of orders by S, that is the cost of order. And that way you get the total ordering cost. And what is this? This is the total inventory cost. Probably you remember that I explained this in class, or I explained this in the seminars. Why these two? This is very logical because this is the order size multiplied by the inventory holding cost. It sounds logical, but what is this two? Remember that in this model we say, we assume that demand is constant, what is not very realistic, but this is what we assume. If demand is constant, every time that we receive an order, we'll be using these units in this order, the same amount every day, and then we will receive the following order, we use the same amount every day, the following one, the same every day, and so on. So if this is the order size, this is the average inventory, okay? As this is constant, we'll say that the half of the order size is the average inventory. Why? Because one day I will have 2009, then I will have 0, 2009, 0, 2009, 0. The average of this, if you add up 2009, 0, 2009, 0, 2009, 0, and you divide, you will get the average that is Q divided by 2, right? So this is the total inventory holding cost. Remember that this is one of the equations. This equation, and the equations for the P models are the equations that you must know by heart for the final exam, okay? All right, so now we work out the total cost with this order size. We will round off, we don't round up, we'll do it with a number, okay? And we will get, excuse me that I have it here. DC 9855, 9855, 000. This will be the acquisition cost. So demand multiplied by the cost. DS divided by Q is 15. And QH divided by 2 is 15, 6, no, 6. You see, we have two equal amounts in here. This means that this is an optimal, right? If we change the order size, if it's a little bit bigger, this will be smaller because we'll have less orders in a year, but this will be bigger, and this will be much bigger than the smaller that this is. This is what it's telling us, that this is an optimal. And the total cost will be 98886 392 67. 67. All right? This is the total cost for this order size of 20928. The order size that this company was using before was 450, no? So the acquisition cost was exactly the same because D and C are not changing. Now the ordering cost will be different. The ordering cost is lower because we have less orders in a year as the order size is bigger, 7,300. And then we have the inventory holding cost that is much, much bigger. Okay, you see, as the order size is bigger, this is the same because the demand and the cost are the same. As the order size was bigger, 450, the ordering cost is much smaller because when you divide the annual demand, 6,570 by 450, you get less orders in a year. and then you include this cost of order less. Okay, that's why this cost is lower than this. But the inventory holding cost is much bigger than this because now every time that you receive an order, it's not 209, it's 450. So the average inventory is bigger. That's why the inventory holding cost with this bigger order size, that is not the optimal, is higher. The total of this is as you can see, this is more costly than this. Okay, so now with this data we can defend before our boss that our decision is good. The difference is almost 10,000 euros. Is 9,657 is the difference between this and this. So our order size implies some savings for the company. All right. So you have shown your boss that you are pretty good. Okay. Now that you feel more confident in the company, you want to go further and you say, oh, I will talk to this supplier and I will try to get a better price. Okay. All right. And now we go to the price break model. You make you make this phone call. You have a meeting with this supplier, and he's not very generous. This is what I have to tell you. And he tells you, okay, I will give you better prices. If your order is from 50 to 200 units, the price will be this price that you have now, 1,500. Nothing will change. Okay? If your order size is from 201 to 500, okay, it will be a little smaller. Okay? If it's more than 500 units, if we're talking about physical objects, this would mean 501. Okay? 501, the price will be 1,497 euros per unit. Okay, so now which is going to be the order size? That's the question. Okay, to know that, what we have to do is to use this equation once and again and again. But we must take into consideration that now we have different costs. This is C, remember, this is C. And, but like C is not here. Is not included here. I think I told you that this comes from differentiating this respect to Q. As Q is not here, this is 0. That's why C is not there. So what we have to do is to compute the 3 potential optimal sizes, and this won't be enough. Okay? Then we will have to decide which one is feasible, which one is not, and then we must try the ones that are feasible and the ones that are not feasible, and a surprise that I have for you, using the formula of the total cost and determining that way which is the one with the lowest cost, and this will be the new optimal. If it's not, that is the same one. Okay? So now we'll see this. We will use this equation 3 times. So we'll have 2 multiplied by 6,570, if I'm not wrong, see? S 500 divided by the inventory holding cost, 150, the 10% of the cost. This is the same upstairs, but not downstairs. This will be 149.8, 26570, 500, 14797, so we will 149.7. Okay, and we get results that are quite similar, but they have different consequences. 209. This is the one that we got before, 209.28. Then we get 209.42. and we get 209.49. Not big differences, okay? And the difference is so small, okay, that it makes not a big difference. But now I have to decide which one of these are feasible and which ones are not feasible or what. Okay. This is the optimal that we decide to use, no? It's not feasible. It's not within this range. It's above the range. We've seen in the examples that we've seen when an optimal was not, a conditional optimal was non-feasible, was below the minimum of the range. We have something new here. This is above the maximum of the range. When it's above the maximum of the range, forget about it, because this is telling you. Remember that the numbers talk. What are you saying? You are above the maximum of the range, so the optimal is above 200. If the optimal is above 200, why paying this price? If it's above 200, you want to pay this price. So forget about it. Okay? Forget about it. If you want, you can try to use this in the total cost equation and see what you get. But I tell you that it doesn't work well. Okay? All right. So in this case, it's not feasible, and we forget about it because it's above the maximum of the range. It's above this. Okay. If you want to keep it simple, and in the day of the exam, for instance, or in the future, you will be the operations manager of a company, and now in this moment you don't remember what's the minimum of the range, was below the minimum, was above the maximum. No worries. Work out the total cost, and then you compare the results, and that's all. If in the day of the exam you are a little bit stressed, I don't know why, but you can be a little bit stressed, and you don't remember in the month, how was it? Below the minimum, above the maximum, which is the one that I have to, don't worry. Work it out, and the result will tell you what to do, okay? But don't take the minimum of the range, because it's above, okay? So in this case, this potential optimal is telling you, what I told you, the numbers talk, okay? Numbers speak. 209, so it's telling you, I want a bigger order, not a smaller order. This is not close to 50, it's closer to 200, so this is telling you a bigger order, not a smaller order, so don't take the minimum of the range, okay? All right, next one. And the green color. The potential optimal that we get is 209.42. This is within this range. Okay? So this is a feasible optimal order size. Right? But this doesn't mean that this will be the final optimal. Okay? Remember, as we don't have C in here, we cannot decide that this is the optimal. What about this? In here we get 209.49. This is not within this range, but it's telling you it's a smaller number than this. So let's take the smallest one in here. Which is the smallest one here? Is 501. Okay? So as we cannot take this, but we like this price because this price is better than this, no? So what we will do is, okay, I cannot take this because if I want 209, my supplier will tell me, no, you cannot have this price. For 209, you have this price. Right? If you want this price, you must order 501, right? That is the minimum in this range. So you say, okay, I will try 501 units. In here you must be very careful with the statement. It's not the same. 500 or more than more than 500. Okay? More than 500 means 501. 500 or more, it means 500. In this case, 501. All right? So now, we forget about this. We will try this, and we will try this. So we will do the equation. Total cost for 209.42 will be the total acquisition cost 6570 multiplied by this acquisition cost 1498 plus the total demand divided by the order size. We're not rounding off nor rounding up, okay? Multiplied by the ordering cost, 500. You can see it, okay? Demand divided by Q, number of orders multiplied by the cost per order, it will be the ordering cost. And then the order size, 20942, multiplied by the inventory holding cost, in this case is this, 1497, divided by 2. And the result in here is I put the total, no widget 3.1. Okay, if you work it out, you'll see that the result of this and the result of this are equal. Okay, because it's an optimal. When it's a feasible optimal, this is what happens. When the optimal is not the feasible one, but the minimum of the range, then these two amounts are not equal. We don't care. Okay. Now let's work it out for 501. So this will be 6570 multiplied by 1497. Aquí me he equivocado, sorry. This was 8. Okay, but the result is correct because it comes from my Excel, right? Is this? Not this. Plus 6570. Aquí cents. 500 is the ordering cost divided by 501. That is the order size. Multiplied by the order size, Q. The inventory holding cost, that is this, now is this, 1497 divided by 2. Okay. It's good to write down here. 497 divided by 2. And this total cost is 501. 909, 346 al cuadrado. No, 346 al cuadrado. So, as you can see, the optimal is not this. In the previous exercise that we had done, a lower acquisition cost was so important that was offsetting some other differences, but not in this case because the difference in the cost is very small and the difference in the order size is big enough. And in this case, what we have is that when it's more than 500 units, when it's 501, especially the inventory holding cost is very big. Okay, if you solve this, you will see that this is much bigger than this, even though this is smaller than this. Is more than bigger than this is, that smaller than this is, and if the difference in the cost that is very small doesn't offset this. Okay, so the winner in this case is this. That is this order size. Okay, so the one that we got with this equation. Okay, so as you see, we can get different results. Sometimes the optimal can be this, or can be this, or can be this. It depends very much on the variables that we are using. All right. So now you know about the price break model, right? Okay, so now we'll do the following video that we'll see about the P models.